Hello dear students, in this lecture we will study technical terms related to lens and we will start our discussion with center of curvature. Till now we have studied that what is a lens, lens types and all the analysis related to them, how they works. In terms of prism we have also studied. Now if we talk about center of curvature, so let us first draw a lens. Okay, so let us first draw convex lens. By convex lens we are drawing. So a lens should have at least one spherical surface. So this will be called as a convex lens. Okay, you are well aware about that. And now the part of which this surface is, the part of that sphere of which the surface is, that sphere, if we complete, means like this, if we complete, so center of this sphere means this point will be known as center of curvature. Okay, so this point is known as center of curvature. So this you can write center of curvature. This is the point of which that lens is the part is known as center of curvature. Okay, so we can also write its definition, but before that let's first erase it. Okay, so let us first write this definition. You can write center of sphere center of sphere whose part is the lens surface. The lens surface is known as center of curvature. Okay, so we have drawn here convex part. Similarly, you can draw the same for convex for concave lens. For concave lens, how you will draw? You will draw the sphere like this. Like this you will draw, and this center portion will be known as center of curvature. Okay, so you can, I hope you have understand till now. So this was the definition of center of curvature. We can also understand that the second portion is also a part of a sphere. Means if it is a convex lens, this part is convex, the other portion can either be convex or concave, or even it can be plane. About plane surface, you can also consider it as a spherical part having infinite radius of curvature. Okay, what is radius of curvature we will discuss in the next portion. Means second point is the radius of curvature. So here you can see, if this is a biconvex lens, or you can even in normally you can say convex lens. So this is a sphere of this part and this is the sphere of this part. So it will have two center of curvature. Okay, two center of curvature. For this portion, its center of curvature will lie here. Means for you can even name them 1 and 2. For first part, first surface, you can say center of curvature will be C1, and for the second surface, center of curvature will be C2. Okay, similarly you can draw for concave lens. If this is a concave lens, now the difference between the two is, let's first draw, this is, let's suppose, okay, these are center of curvature for respective surfaces. Now if again let's call this surface as 1, this for 2. Center of curvature for surface 1 will lie in left portion, you can say C1, and center of curvature for second surface will be at C2, which is at the right of the lens, which is exactly opposite in the case of convex lens. So in case of convex lens, for first portion, the center lies right from the lens, means for this part it is toward this, toward here, and the second, for the second surface, the center of curvature is toward left. But in this case, for concave lens, the analysis is just opposite. For first surface, the center of curvature lies in the left, and for second surface, it lies in the right direction. Okay, so this is about center of curvature. Now let us discuss radius of curvature. Let's again draw, or you even need not, we need not to draw that again. Now the surface is this one. Let's talk about this one. The spherical portion, or of which the sphere, or you can say this lens is a part of that sphere. It is a complete sphere, and this lens is just a part of that sphere. Now the radius of this sphere, radius, this is known as radius of curvature. Similarly, for this portion you can also say this, let us call this R1, this is R2. So these are radius of curvature. Similarly, here you can also draw, this is R1, this is R2. Okay, so these are radius of curvature. So you can write this definition: the radius of curvature whose radius of curvature, you can say, yeah, or sphere, actually sphere you should say, you can write, whose part is the surface, or lens surface, you can write lens surface, is called radius of curvature. Okay, this is called radius of curvature. You can see here the radius of curvature of these two parts can have different value. Okay, for this it is R1, for this this surface it is R2. If radius of curvature of these two parts are same, then we will call this lens as equiconvex lens. Equiconvex lens. Similarly, if radius of curvature for these part are also same, means R1 is equal to R2 in this situation, you can call that equiconcavo or equiconcave. Equiconcave. Okay, so you can also write for both the surfaces value of radius of curvature is same. Since we write for convex lens, so in definition you can mention convex for both the surfaces in convex lens. Convex lens you can also write convex lens. Okay, same will happen in this situation. Same you can write for this. If the radius of curvature for both the spheres or both the spherical part is same, then you can say that lens will be equiconvex lens or equiconcave lens. Okay, so this is the case. Now let us further discuss principal axis. So principal axis is, you can say, these are two centers, this one and this one. The line joining these two center is known as principal axis. Okay, similarly for this also you can say. So for this you can write the line joining the two centers of sphere of which length is the part. This portion you can write in parenthesis. The line joining the two centers of sphere is known as principal axis. Okay, so if it is a lens, then you can draw this line will be principal axis. This line will connecting the 2 point center of curvature of these two spherical surfaces. Similarly, you can also draw for concave part. This is principal axis. Okay, so this is principal axis. Now let us discuss optical center. So about optical center, you can write it is the point on which if a ray comes, then it will go undeviated for a very thinness, or if thin is little bit thicker, then the emergent ray will be parallel to incident ray. Okay, so you can write it is a point on principal axis. First of all, it lies on principal axis. Okay, it is a point of principal axis of the lens such that a ray of light passing through this point emerges parallel to direction of incident ray, you can say. Okay, means what does it mean? It means that if it is a lens, then optical center is that point. If a ray is coming in its way, means if a ray is coming like this, the lens will deviate the ray in such a manner that it will go parallel to, actually in actual what happens in actual, refraction take place in two surfaces, in this surface and in this surface. In both the surface refraction take place. However, when we draw in lens, we always show them in very middle point, means actual what happens, what we draw like this, but what in actual it happens that it will deviate here, it will deviate here, and then it will go like this. Okay, but for simplicity we draw at one point only, like this, we show like this only. Okay, so what happens in actual is that if a ray is coming like this, so it will bend like this, that this ray will be parallel to this one, means incident ray and emergent ray will be parallel. So the point toward the incident ray is pointing is known as optical center. Okay, so there is another definition you can write for optical center, that uh, it is a more general definition. However, specifically you can say optical center of a lens is that point Actually, this definition we are writing for thin lens particularly. So you can also mention optical center of a thin lens. Of a thin lens is the point on principal axis of lens such that a ray of light directed toward it will go undeviated, will passes undeviated to it through it through it. Okay, so this you can write for optical center. Okay, so this is optical center. So a few things we have discussed till now: center of curvature, radius of curvature, principal axis, and optical center. Further things we will discuss in next lecture. Okay, so thank you so much for watching the lecture.